Okay, in this lesson, we'll be looking at trigonometry and circular functions. So up to this point, all we've done is right triangle trigonometry. So we were bound by the right triangle, meaning the thetas that we worked with were all acute angles. So theta was bound by being between 0 and 90 degrees. But when we transition to circular trigonometry, we're working on a Cartesian plane, and the angle can be any angle, both positive, negative, and anything. So we're no longer bound by theta being an acute angle. But when we start working with circular functions, theta can be pretty much any number there is. So we'll look at particular situations to kind of build us to where we need to be. So if we had our Cartesian plane and we had an angle, theta. If I drew a circle, the angle intersects the circle at a particular point. This point has coordinates x and y. So if we take this point here and begin to project vertical and horizontal lines to illustrate exactly where the x coordinate would be and where the y coordinate would be, that helps us. And of course, from here to here is our radius because we do have a circle. And the distance from the center out to the circle would be our radius. So we have these three variables, the x coordinate, the y coordinate, and r for our radius. Well, this can help us kind of focus in on a particular triangle. No, we're not working with a triangle, but this illustration leads us into transitioning from the triangle into the Cartesian plane. So if this is the case, our coordinates can actually be represented by the lengths of the different sides of our right triangle. So what's happening now is if this was the triangle, y would be our opposite side, x would be the adjacent, and r would be the hypotenuse. So we're transitioning. In right triangle trigonometry, we were bound by the words opposite, adjacent, and hypotenuse. Now that we're on the Cartesian plane, we're now using the variables x, y, and r. So that means our 6 trigonometric functions with the corresponding ratios will now have new ratios. So instead of using the words opposite, adjacent, hypotenuse, we'll be using y, x, and r. So sine used to be opposite over hypotenuse. Now it'll be y over r. Cosine was adjacent, which is the x, over hypotenuse, r, x over r. Tangent was opposite over adjacent. Now opposite is y, adjacent is x, y over x. And then the other three will simply be the reciprocals. R over y for cosecant, secant r over x, and cotangent x over y. Now there's one caveat here. Because we are working with these three variables, x, y, and r, x and y do represent coordinates. So therefore, x and y can't both be 0. Because if they both were 0, we'd have the ordered pair, 0, comma 0, which puts us at the origin. So we wouldn't ever have the ability to create an angle and therefore the triangle. Also, r. R is actually found by using a version of Pythagorean's theorem because r is still what would have been the hypotenuse. So if it was Pythagorean's theorem, it would have been A, B, and C. So it's just a variation of Pythagorean's theorem. So we'll begin to explore actually applying this. So it says, let theta be an acute angle and standard position whose terminal side contains the point 5, 3. Find the 6 trigonometric functions. So we know for certain that x is 5, y is 3, and we need to just determine r. Why? Because if we're trying to find the 6 trigonometric functions, the 6 trigonometric functions all now use in their ratios the letters x, y, and r. So we essentially just apply Pythagorean's theorem, using x's, y's, and r's instead of a's, b's, and c's. Substitute our values in, simplify, continue, and now square root on both sides. The radius, r, is the square root of 34. So now that we have all three values, we can now substitute it into the 6 trigonometric functions. Sine would have been y over r. We simplify that. 3 radical 34 over 34, because I can't leave my radical in the denominator. I have to rationalize the denominator. Cosine would have been x over r. X was 5. R is still my radical 34. Again, simplify that for our final answer. Tangent is y over x. No need to simplify because it is already. Cosecant is just a reciprocal, so I wouldn't take the reciprocal of this. I still start with r over y. Done. Same with secant, r over x, and cotangent, x over y. Try a different one. Now we're working with the same numbers, but it's just in a different quadrant. So the only difference is the 3 is negative here. But the procedure is the exact same. So I got my x, my y, and we just need to find our r. Set up our Pythagorean theorem. Substitute the values in. We'll get the same 25 and 9. Gives us the same 34, radical 34. So the only difference with our answers now is that wherever we use the y, the 3 will be negative. So there's our negative 3. Simplify. Negative 3 radical 34 with 34. Cosine won't change. There's our tangent, negative 3/5. Again, all I did is just make it look more like a negative fraction. Again, the reciprocal, I'll do the same thing, make it look like a negative fraction. Secant, and then cotangent. Again, I'll make it look like a negative fraction. So the next example will be very similar to the one that you'll be using in Desmos. Let theta be an angle in standard position whose terminal side contains this point. I only am asking you to find secant. Secant is the reciprocal of cosine. Cosine was x over r, so I just need to find r over x. So set it up the same way. We have our x, our y, and we'll work to find r. We'll first substitute it into our version of Pythagorean's theorem. Substitute the values in. Now don't let this confuse you here. I could just type all of this into the calculator, but the square root of 7 squared, the squaring and the square root actually cancel each other out. So I'm just left with 7, not negative, because a negative times a negative is a positive. Negative 2 squared, 4. Simplify, and then solve, we get radical 11. Notice, no decimals. Everything is exact. So now that I have all the variables I need, secant, again, is r over x. The r is radical 11. The x is negative radical 7. I could substitute this straight into the calculator, so I'll do that just to illustrate. All right, clear, we had radical 11, right? What was it? Radical 11 over negative radical 7. All right, radical, I even set that up. Radical 11 over negative radical 7. Let the calculator do it all for you. There we go. Negative radical 77 over 7. There's our answer. Got one more example to do. Let theta be the angle in standard position whose terminal side contains this point. Negative radical 5, comma, radical 3. Because we're finding sine, we need to know the y and the r. So we got our x, our y, and we're just going to work to find the r. Substitute our values in. And again, the same thing is going to happen. When we square this, we get 5. When we square this, we get 3. 5 and 3. There's my 8. Square root of 8. The square root of 8 can be simplified. That's 2 radical 2. Just to confirm, the square root of 8, second square root of 8, there's our 2 radical 2. So again, let the calculator do some of this work for you. Don't need any of that. Back to it. So, sine is y over r. Got our y is radical 3. We got our r, 2 radical 2. Substitute this straight into the calculator. It will say radical 6 over 4. Okay, so these examples should assist when doing the practice.